Okay, we're here in Berkeley with Dan Granette. He's a prototyper, designer, and his specialty is precision machining. We talked about the design of a multi-purpose precision machine, kind of like a mill right here with many purposes that can handle milling, drilling, lathing, also surface grinding, cold cut, and some other functions. So Dan, tell us more about this. What's our concept so far?
Most important aspect, in my view, is rigidity of the machine. Most DIY CNC devices are flexible, and when you have a cutter pushing into a big block of steel, its tendency is to want to react and move away from it, and you can't let that happen.
Mm-hmm.
If you're using a high-speed router, that works fine in wood or maybe aluminum, but if you're cutting big chunks of metal out, you don't want there to be any flexibility, not even a thousandth of an inch. And so that's what we'll be designing, is something that has a massive base structure.
Mm-hmm.
And
yeah.
anything you do on that, at least you know the structure's not going to move.
Yeah. Well, tell us about your experience as far as precision machining. What's your background on that?
Right out of college, I tried to get a job at Jet Propulsion Lab in Los Angeles, and they asked me, well, can you run machines? And I said no, and they said, come back when you learn, when you know how. And I took the CETA course in the 80s in Los Angeles, and it was a precision machinist 12-week intensive course, and I learned how to use all the different machines, and basically got back into JPL and started making little gadgets for them, and ended up working with supporting some of the shuttle flights, and gadgeteering mostly.
Yeah.
And, after that, just went off on my own.
Yep.
And been supporting local labs, Lawrence Berkeley, and anybody that doesn't have their own shop. I build little gadgets for them. What's
the range of prototyping? So prototyping that you do, what kind of things?
All kinds of materials, molding, plastics of all kinds, metal casting, bronze casting, all the different welding, MIG, TIG, some titanium welding, machining. I have access in other shops around the area to do abrasive water jet and EDM wire, EDM sinking, just about anything, laser cutting of all kinds, laser machining.
Yeah.
Yeah.
As far as so we're gonna get you in on a Kickstarter to work on a precision CNC multi-machine, and we're gonna come up with a proposal. It's gonna be basically the concept is an open source micro factory to bring a lot of the flexible fabrication concepts together. Yeah. So we'll keep knocking out the design. So what can we do, like, say, in the next month as we prepare for Kickstarter? What can we get as far as the concept and the deliverable defined?
I think we can pretty well design a system that will be extremely rigid, and will be able to take found pieces of steel and machine them slightly to get accurate weighs, and either attach them to a pre-made base, either welded or cast. Concrete base has been used historically in machine tools, and the more rigid the better. And massive is not a problem. It's inexpensive, and it's a good place to start from for your 3 axes, and then we'll figure out a way to move each axis.
So a low cost, like the best low cost strategy for the XYZ motion, right? And so what are we thinking about that?
We can use stepper motors, servo motors. We could have converted motors turned into stepper motors for a very inexpensive use and high torque, such as alternators, 12-volt automobile alternators, Acme threads with
digital readout,
with bronze nuts so that the turning of the Acme thread screw will move each axis. Possibly a do-it-yourself digital readout based on fine pitch lithography pattern on materials that are etched into materials and read out with LEDs, little laser diodes.
Possibly Arduino.
Arduino for controlling CNC eventually, and reading.
And the readout of the position?
The position from computer files, yes.
Mm-hmm.
From basic drawing programs, of which there are many freeware and shareware programs.
Yeah.
Source programs, yeah.
Yep.
It should be quite doable.
Yeah. Yeah, so Dan's a subject matter expert in precision machining. We're glad to have him on the team, and we'll see how far we can go. And we're also going to be looking for a lot of different collaborators on the open source microfactory, so stay tuned in. And Dan, thanks a lot. Any final comments or anything for the crowds?
No, this is fun, and this will probably produce a more rigid machine than any out there that have been homemade and home-makeable.
Yeah. What kind of price are we looking at? I hope we can go between $3,000 and $5,000 for a complete super heavy-duty multi-machine that includes cold cut and surface grinder. So if we can do that, we'd like to do things like hydraulic motors, steam engines, electrical generators with this kind of a device. You think we can do it?
I think it's doable.
Mm-hmm.
With a modular system that allows you to plug your tool device into a PTO, a power takeoff, on the machine, everything run by one or two major hydraulic motors, that should be able to run anything. So you could quickly stop and clear one project, work on another one, remove that, and continue on the other project.
Yeah. Yeah, this is excellent. So it sounds like some progress for the eventual DIY fabrication facility for a sustainable village, open source village, coming home close to you in the near future.
Exciting.
Okay, thanks, Dan.
Thanks, Marcin.